Hi students, in this video we are going to discuss clearly and as well as briefly about the different kinds of the groups. Group 15, group 16, group 17 and group 18 elements. Now let us come to group 15 elements. These group 15 elements are also called nitrogen family. Why they are called nitrogen family? Because they start from nitrogen. See, if you observe this group of elements are so vigorous. In this group, the vigorous element is phosphorus. They can show the property of combination and as well as catenation. Phosphorus is of 5 types. Red phosphorus, black phosphorus, yellow phosphorus, scarlet phosphorus, like that. Various types are there. Vigorous. And you already know nitrogen percentage is about 81% is there in the nature. We already know. Means more amount of these elements are there. If you see this arsenic, the use of arsenic is used in the wristwatches. While in the preparation of the dial of the wristwatch, we are using more amount of the arsenic. This arsenic is only the main ingredient in rocket propellants. So more use is there in the case of arsenic. Antimony. While using the stunt is nothing but not in the cinema stunt. While the doctor is going to use now heart surgery, those stunts, main ingredient is antimony. Bismuth. Comes to the bismuth. Bismuth is placing a very important role in the dentition. Whenever you go to a dentist, they will put some cement. The cement and as well as another cement is not same. Both of them are different. The cement used by the dentist mainly contains bismuth oxide. Very, very important concept. Right. Now comes to the symbols: nitrogen N, phosphorus P, arsenic As, antimony, this is called stibium. The Latin name of antimony is stibium Sb, bismuth Bi. Come to their atomic numbers: nitrogen 7, phosphorus 15, arsenic 33, stibium Sb 51. Atomic number of bismuth is 83. Now right, comes to the electronic configurations: nitrogen 7, 1s2, 2s2, 2p3. Their valency shell is 2. Here is the valency shell and the valency electrons are 5. How the 5 electrons? 2 electrons belongs to s orbital and 3 electrons belongs to the p orbital. So total number of electrons are 5. We know that the total number of electrons that present in the valency shell is called valency electrons. So here the valency electrons are 5. Now let us come to the phosphorus with the atomic number 15. Observe here the valency shell is equals to 3. Valency electrons are 5. Valency shell is 3. Outermost shell of the electronic configuration is called valency shell and the valency electrons are 2 plus 3, that is 5. Now let us come to the arsenic with the atomic number 33, whose electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. By rearranging we can get 4s2, 4p3. 4s2, 4p3. So the valency shell becomes 4. Valency electrons are 5. Valency electrons are 5. If you observe, in the case of stibium Sb with the atomic number 51, here by rearranging we can get 5s2, 5p3. So here the valency shell is equals to 5. Valency electrons are also 5. From this explanation we can understand that what is the general electronic configuration: 2s2, 2p3, 3s2, 3p3, 4s2, 4p3, 5s2, 5p3, 6s2, 6p3. So generally it can be represented as ns2, np3, where n starts from 2, 4, 5, 6. Now, what are the valency electrons? Final electrons are nothing but valency electrons. Here the valency electrons are 5, here also 5, here also 5. So the valency electrons are 5. Now, which block elements these are all? See, the differentiating electron enter into the p orbital. Here also the differentiating electron enter into the p orbital. Here the differentiating electron enter into the p orbital. In this case also the differentiating electron enter into the p orbital. So this group, that is 15th group, belongs to p block. Finally, we can say this group 15 elements general representation is ns2 np3. Their valency electrons are 5. They belongs to p block. Now let us discuss group 16 elements now. Now group 16 elements, they start from oxygen, so they are also called oxygen family. A special name is given here, chalcogens. Chalcogens is nothing but ore forming elements. Means in the Earth's crust, many of the metals are ready to react with these elements. Sodium react with oxygen, magnesium react with oxygen, calcium, aluminum, like all such kind of the metals are ready to react with the oxygen and as well as sulfur. So many of the ores are there in the form of their oxides. For that sake only they are also called chalcogens. Chalco means ore. Now let us come to those group elements: oxygen O, sulfur S, selenium Se, tellurium Te, polonium Po, livermorium Lv. We already know about the oxygen. Without oxygen we can't breathe. Sulfur, mainly we are using the sulfur while in the preparation of matchboxes and firecrackers. Next, selenium is used in the preparation of watches. Tellurium, nuclear reactors we are going to use. We know famously polonium, which was discovered by Madame Curie, and she kept her motherland name, that is Poland. Last one, livermorium. It was discovered by Henry Ford, but he kept his land name Livermore in USA. Now, their atomic numbers are oxygen 88, sulfur 16, selenium 34, tellurium 52, polonium 84, livermorium 116. And by going on writing the electronic configuration of oxygen 1s2, 2s2, 2p4, their valency shell is 2. Here their valency shell is 2 and the valency electrons are 6. The 2 electrons belongs to s orbital and 4 electrons belongs to p orbital. Now let us come to the sulfur. In the case of the sulfur, their general electronic configuration here 3s2 and as well as 3p4. So the valency shell is 3, but the valency electrons are 6 only. Now comes to the selenium, the atomic number 34, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. By rearranging, we can get the valency shell as 4, but the valency electrons are 6. How the 6 is came? 2 electrons belongs to the s orbital and 4 electrons belongs to the p orbital. Now here by rearranging it becomes 5s2, 5p4, so the valency shell is 5, valency electrons are 6. Now if you observe the total group, what is the general electronic configuration? 2s2, 2p4, 3s2, 3p4, 4s2, 4p4, 5s2, 5p4, 5s2, 5p4, whereas well as 6s2, 6p4. Generally we can write ns2, np4, where n starts from 2, 3, 4, 5, 6, 7. Now what are the valency electrons? The valency electrons are 6. Which block this is? Block depends on the differentiating electron. Here the differentiating electron enter into the p orbital. In this case also the differentiating electron enter into the p orbital. Here also the differentiating electron enter the p orbital. So if you observe the total group differentiating electron enter into the p orbital. So these are all p block elements. Now let us finally we can say group 16 elements, the general representation is ns2 mp4. Valency electrons are 6. Which block? P block. These are all the final information or general information we can get from this explanation. Now let us discuss group 17 elements now. Students, in this group 17, that is called fluorine family or halogens. Why? Because the formed compounds are called halides. They are light in weight, so further they are called halides. The elements are fluorine, chlorine, bromine, iodine, astatine. Fluorine, chlorine, bromine, iodine, astatine are the elements that are present in this group. Their symbols are F, Cl, Br, iodine, At. The atomic number of fluorine is 9, chlorine is 17, bromine is 35, iodine 53, astatine 85. Now come to the electronic configuration of fluorine 1s2, 2s2, 2p5. Here the valency shell is 2. So the valency shell is 2. Count the valency electrons. The valency electrons are 2 plus 5, that is 7. Now come to the chlorine, atomic number is 17, 1s2, 2s2, 2p6, 3s2, 3p5. So valency shell is equals to 3 and the valency electrons are 7. Now let us come to the bromine, atomic number 35. By reorganizing, we can write 4s2, 4p5. 4s2, 4p5. So the valency shell is 4 and the valency electrons are 7. Here 2 electrons and this becomes 5 electrons. Valency electrons are 7. Now atomic number 53. By rearranging, we can write 5s2, 5p5 is the valency shell. So the valency shell is equals to 5 and the valency electrons are 7. Now let us come to astatine. If we are going on writing the electronic configuration, we can get the valency shell as 6s2, 6p5. So the valency shell is equals to 6. Valency electrons are 7. Now if you understand the total representations, we can write the general electronic configuration can be written as ns2 np5, ns2 np5, 2s2 2p5, 3s2 3p5, 4s2 4p5, 5s2 5p5, 6s2 6p5. So generally we can written as ns2 np5, where n is equal to 2, 3, 4, 5, 6. Now let us come, what are the number of valency electrons? We already know valency electrons are nothing but total number of electrons that present in the valency shell. Here the valency electrons are 2 plus 5, that is 7. Here also valency electrons are 2 plus 5, that is 7. Here valency electrons are 7. So the valency electrons we can write them as 7. Right? Good. Now which block it is? Which block? Differentiating electron enter into the which orbital, that we should see. Differentiating electron enter into the p orbital. So these are all we can say, these are all p block elements. These are all the elements are p block elements. The general electronic configuration, finally we can summarize. Group 17, ns2, np5 and the valency electrons are 7. These are all which block? p block elements. Why? Because the differentiating electron enter into the p orbital. Now let us discuss group 18 elements now. Group 18 elements are also called noble gases, inert gases, rare gases. Why they are called noble gases? First of all, the element krypton is the noblest element. Inert gases, that does not react with any other element. They have more inert. The word inert is nothing but which does not react with the other is called inert. Rare. The percentage, volumetric ratio of this percentage is 0.00001% only. So for that, the percentage is less. Now let us come, what are those elements? Helium, neon, argon, krypton, xenon, radon. Helium He, neon Ne, argon Ar, krypton Kr, xenon Xn, radon Rn. With their atomic numbers are 2, 10, 18, 36, 54 and 86. Now, if we are going on writing the electronic configuration of helium is 1s2. See, here valency shell is 1 and as well as valency electrons are 2. Comes to the neon, 1s2, 2s2, 2p6 we can write. Here the valency shell is 2, valency electrons are 8. Argon, valency shell is equals to 3, valency electrons are 8. 2 electrons are from s orbital, 6 electrons from p orbital. Now come to the krypton, atomic number 36. 1s2, 2s2, 2p6, 3s2, 3p6, 3s2, 4s2, 3d10, 4p6. By rearranging, we can get the valency shell as 4, valency electrons are 8. Now, let us observe xenon. By rearranging, we can get 5s2, 5p6. So the valency shell is 5 and the valency electrons are 8. When compared to the radon, valency shell is equals to 6, valency electrons are 8. If you observe, except helium, remaining all the inert gases, they have valency electrons as 8. So the valency electrons of this group is 8 except helium. Now, let us come to the general electronic configuration. General electronic configuration, keep the helium aside, then remaining observe 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6, 6s2, 6p6. So the general electronic configuration is ns2, np6 except helium. Then why there is an exception is there here? Though there is an exception is there, helium properties, physical and chemical properties of the helium resemble with the physical and chemical properties of other inert gases like neon, argon, krypton, xenon and radon. So, though there is a difference in the electronic configuration, we arranged the helium along with these inert gases. Compulsory we should give the exception. So the general electronic configuration is ns2, np6 except helium. Now valency electrons are 8 except helium. In the case of helium, valency electrons are 2. It is called doublet configuration. Here 8 electrons are there. It is called octet configuration. Every inert gas has 8 electrons in its valency shell, so that is called octet configuration. Now let us come to the block. Which block this is? Except helium, remaining all the elements of inert gases, valency electron, that is the differentiating electron, enter into the p orbital. Here p orbital and here also enter into the p orbital. So this is p block element except helium. That's it. So but properties are similar. For that sake only we are attached the helium with the inert gases. Now finally we can conclude group 18 elements. Their general representation is ns2 np6 except helium. Their valency electrons are 8, which is called octet configuration except helium, and they belongs to p block except helium. Though they belongs to the S block, but we added in the P block because of the similar properties of the other inert gases. Thank you.